Hello students, today we are going to discuss on the topic consequences of high specific latent heat of fusion of ice, chapter calorimetry. Now let's proceed with the objective of the day. Consequences of high specific latent heat of ice, and the questions involved in this topic will be: why snow on the mountains does not melt at once? In cold countries, water doesn't freeze at once. Drinks get cooled more quickly by adding a piece of ice than water at 0 degree. When ice in frozen lakes starts melting, the surroundings become very cold. It is generally more cold after a hailstorm than during or before hailstorm. Now let's proceed. Snow on the mountains does not melt all at once. Let's see few pictures. Here we can see mountains which are not completely filled with snow. Here also we can see mountains, but they are not completely covered with snow. Now what is the reason that snow on the mountains does not melt all at once? Ice has a very high specific latent heat of fusion. Its value is 336,000 joule per kg. Now what is the meaning of this thing? 1 kg of ice, it means 1 kg of ice which is at 0 degree will absorb how much of heat? 336,000 joule of heat from the surroundings and convert it into water at 0 degree. Now when ice is going to be converted into water, so it has to absorb heat. And how much heat it will absorb? Ice will absorb 336,000 joule of heat. And how much amount of ice? 1 kg of ice. Since this value is too high, ice takes a lot of heat and time to melt. Hence, we can say that snow on the mountains doesn't melt all at once. Now let's read the chapter. Snow on mountains does not melt all at once. The reason is that ice has a high specific latent heat of fusion equal to 336,000 joule per kg, which we have already done. It is due to this fact that it changes into water slowly. Because its value is very high, so ice melts very slowly as it gets heat energy from the sun. If latent heat would have been low, all the snow would have melted in a short time on getting heat from the sun, and obviously what will be happening then? Then there would have been flood in the rivers. I hope you have understood. Now next thing. In cold countries, water doesn't freeze to ice at once. Let's see a picture. Here we can see ice as well as water. Here also ice and water. Now why in cold countries water doesn't freeze to ice at once? The reason is ice has a high specific latent heat of fusion. Its value is 336 joule per gram. Now we can take it in joule per gram or in joule per kilogram also. This means that every 1 gram of water at how much? 0 degree will release. Now when water is going to convert into ice, obviously it will release the heat. And how much heat? 1 gram of water will release how much heat? 336 joule of heat. At what temperature? At 0 degree. And hence it will give the heat to the surroundings and convert into ice at 0 degree. This heat is released to the surroundings and make it hot. Hence, we can say that in cold countries, water doesn't freeze to ice at once. Now let's read. In cold countries, water in lakes and ponds does not freeze all at once. The reason is that the specific latent heat of fusion of ice is sufficiently high. The water in lakes and ponds will have to liberate a large quantity of heat to the surrounding before freezing. The layer of ice formed over the water surface being a poor conductor of heat. Ice is a poor conductor of heat and hence it helps the aquatic animals to survive also. Will also prevent the loss of heat from the water of lake and hence it does not freeze all at once. Now the next topic is when ice in a frozen lake starts melting. Now we have lake which is filled with ice. When it starts melting, its surrounding become very cold. What is the reason? Ice has a very high specific latent heat of fusion. Its value is 336,000 joule per kg. And what is the meaning of this thing? It means 1 kg of ice, how much it will absorb the heat? 336,000. Now here I have written absorb. Why? Because we have ice and we have to convert it into water. The condition is we have to convert ice to water. So for this thing, ice will obviously have to absorb the heat. When ice will absorb the heat, it will be converted into water and at 0 degree. This makes the surrounding cool. Since it absorbs the heat, so surroundings will become cool. Hence, we can say that ice in frozen lake, when it starts melting, its surrounding become very cold. I hope you have understood. Now, book reading. When ice in a frozen lake starts melting, its surrounding become very cold. The reason is that quite a large amount of heat energy is required for melting the frozen lake, which is absorbed from the surrounding atmosphere. As a result, the temperature of the surrounding fall and it becomes very cold. Now the next topic is drinks get cooled more quickly by adding piece of ice than water at 0 degree. Here we have a drink and it is filled with ice in a small amount. Now what is the reason behind drinks get cooled more quickly by adding piece of ice than water at 0 degree? Ice has a very high specific latent heat of fusion. Its value is 336 joule per gram. Again I have taken in joule per gram because we are talking about the drinks. So what does it mean? It means that 1 gram of ice which is at 0 degree, what will it do? It will absorb the heat. How much heat? 336 joule of heat. From where? From the surroundings, to convert into water at 0 degree. And the surrounding means we are talking about the drink. This produces a cooling effect. Hence, ice produces a large cooling effect as compared to water at 0 degree. Now let's read from the book. Drinks get cooled more quickly by adding pieces of ice than the ice cold water at 0 degree. This is because 1 gram of ice at 0 degree, it will take how much of heat? 336 joule of heat energy, which is very large, from the drink to melt into water at 0 degree. Thus, the drink liberates an additional 336 joule of heat energy to 1 gram of ice at 0 degree, then to 1 gram of ice cold water at 0 degree Celsius. Therefore, cooling produced by 1 gram ice at 0 degree is much more than that by 1 gram of water at 0 degree. I hope you have understood. The next topic is, it is generally more cold after hailstorm than during or before hailstorm. Let's see some pictures. Here we can see hailstorm. Here also. Now what is the reason? It is generally more cold after hailstorm than during or before hailstorm. Ice has a very high specific latent heat of fusion. The reason is this. And what is its value again? Its value is 336 joule per gram. Now what does it mean? 1 gram of ice, what will it do? It will absorb how much of heat? 336 joule of heat. And at which temperature? 0 degree. From where? From the surroundings, and it will convert into water at 0 degree and make the surroundings cool. Hence, it is generally more cold after hailstorm than during or before hailstorm. Now let's read from the book. It is generally more cold after a hailstorm than during or before the hailstorm. The reason is that after the hailstorm, ice absorbs the heat energy required for melting. Now we have ice, and ice has to become water. Naturally, it is a natural process. So to become water, what will it do? It will absorb the heat. And when it will absorb the heat, the temperature will go down. So the temperature of the surroundings falls further down and we feel more cold. I hope you have understood the topic, students. Thank you.